Satellites. Satellites are made for telecommunication purposes. They are used for mobile devices, such as ships, vehicles, aircraft, portable terminals, TV and radio communications. They are responsible for providing an allocated region, area, on Earth with these services. Satellite orbit. There are two main types of satellite orbit. 1. Circular orbit, which is an orbit that has an eccentricity of 0 and whose path traces a circle. 2. Elliptic orbit, which is an orbit with an eccentricity greater than 0 and less than 1 whose orbit traces the path of an ellipse. As we can see from the second picture, there are 2 points to distinguish. First is apogee, which is the highest or farthest point from the Earth for an object in orbit around the Earth. Second point is perigee, which is the point in the orbit of an object circulating the Earth when that object is close. There are 3 main classification of satellite orbit. 1. Inclination classification. Equatorial orbit. Polar orbit. 2. Eccentricity classification. Circular orbit. Elliptic orbit. 3. Altitude classification. Satellite orbit. There are 3 types of satellite orbits. 1. Low Earth orbit, called LEO. 2. Medium Earth orbit, called MEO. 3. Geostationary Earth orbit, called GEO. All types will be explained in the following slides. 1. Low Earth orbit LEO. LEO is much closer to the Earth than geosatellites, ranging from 500 to 1,500 kilometers above the surface. LEO satellites don't stay in fixed position relative to the surface, and are only visible for 15 to 20 minutes each pass. Revolution time of LEO is 90 minutes to 3 hours. Advantages of LEO. 1. Reduces transmission delays, point-to-point communication. 2. A LEO satellite's smaller area of coverage is less of a waste of bandwidth. 3. Eliminates need for bulky receiving equipment. Disadvantages. 1. Shorter lifespan, 5 to 8 years, than GEO's, 10 years. 2. A network of LEO satellites is needed, which can be costly. Examples of low Earth orbit. Earth resource management. Landsat. Spot. Radarsat. Paging. Orbcom. 2. Medium Earth orbit, MEO. Also known as Intermediate Circular Orbit, ICO. MEO satellite is in orbit somewhere between 8,000 kilometers and 18,000 kilometers above the Earth's surface. MEO satellites are similar to LEO satellites in functionality. They are visible for much longer periods of time than LEO satellites, usually between 2 to 8 hours. MEO satellites have a larger coverage area than LEO satellites. Advantage of MEO. MEO satellites' longer duration of visibility and wider footprint means fewer satellites are needed in MEO network than LEO network. Disadvantage. MEO satellites' distance gives it a longer time delay and weaker signal than a LEO satellite, though not as bad as a GEO satellite. Examples of MEO. Global Positioning System, 20,200 kilometers altitude. 3. Geostationary Earth orbit, GEO. These satellites are in orbit 35,863 kilometers above the Earth's surface along the equator. Objects in this orbit revolve around the Earth at the same speed as the Earth rotates. This means geosatellites remain in the same position for infinity time relative to the surface of Earth. Communication satellite and weather satellite are given this orbit. Advantages. 1. Geosatellite's distance from Earth gives it a large coverage area, almost a fourth of the Earth's surface. 2. Geosatellites have a 24-hour view of a particular area. 3. These factors make it ideal for satellite broadcast and other multi-point applications. Disadvantages. 1. Geosatellite's distance also cause it to have both a comparatively weak signal and a time delay in the signal, which is bad for point-to-point communication.
Satellite footprints. The area of the Earth covered by the microwave radiation from a satellite dish, transponder, is called the satellite's NBSP footprint. NBSP, the size of the footprint depends on the location of the satellite in its orbit, the shape and size of beam produced by its transponder and the distance from the Earth. The footprint can be seen as the area in which a broadcast signal from a particular satellite can be received. The area on the surface of the Earth within a satellite's transponder, transmitter or sensor, field of view. Limitations of footprints. Footprints show general coverage for regions and therefore any boundary is indicated by the footprint maps, should NBSP, not NBSP, be interpreted as a rigid limit. The quality of reception can be vary at different places short distances apart. NBSP. This occurrence is more noticeable as the frequencies increases. The difference between high and low frequencies are 1. Low frequency. Can travel around the world. Has low energy power. Needs a bigger dish. Minimal interference by clouds. 2. High frequency. Are mostly straight line of sight. Have a lot of energy power. Scatters very easy into different directions, by severe storms. Needs a smaller dish. Satellite link budget. Satellite link budget is the process of calculating all the gains and losses from the transmitter device to the receiver through the medium. It calculates the attenuation of the transmitted signal due to propagation as well as the antenna gains, feed line and miscellaneous losses. Objectives of calculating link budget. 1. To make the radiated power sufficient. 2. A simple link budget has to be computed for a single link corresponding to the worst case. Types of satellite links. There are two types of satellite links. 1. Satellite uplink, which is the process of transmitting signals from Earth stations to the satellite and the satellite is receiving it. There are some transmission losses. The losses which are constant such as feeder losses are known as NBSP, constant losses. No matter what precautions we might have taken, still these losses are bound to occur. Another type of losses are NBSP, variable loss. The sky and weather condition is an example of this type of loss. Means if the sky is not clear, signal will not reach effectively to the satellite or vice versa. Second types of satellite links is satellite downlink. In this process, satellite sends the signal and the Earth station receives it. The frequency at which the satellite is communicating with the Earth station is called downlink frequency. Advantages and disadvantages of satellite system link models. Advantage 1. It is used for mobile and wireless communication applications independent of location. 2. It covers wide area of the Earth, hence entire country or region can be covered with just one satellite. 3. It provides wider bandwidth based on SCPC or MCPC allocation types. Disadvantage 1. Satellite manufacturing requires more time. Also, satellite design and development requires higher cost. 2. Satellite once launched, requires to be monitored and controlled on regular periods so that it remains in the orbit. 3. Satellite has life which is about 12 to 15 years. Due to this fact, another launch has to be planned before it becomes unoperational.